So, welcome back to another episode on the channel. On this episode, I'm going to cover the stack a dime MIG welding technique, or techniques you can use to get that look. And if you need an expensive machine to do it, do you need a Lincoln or a Miller or a Hobart or Everlast to get that look, that quality weld like that? Or can you do it with the cheaper Harbor Freight machine? And the answer is yes. Yes, you can do it with the cheaper machine if you know how to get the correct settings and the correct techniques used to get that look. Now, I'm not trying to say that the Harbor Freight machine is as good as the Miller welding machine, but what I am trying to say, for a lot of people on a budget, if you compare the titanium MIG weld machine from Harbor Freight that we'll be using for the video versus the Miller 211, it's about $1,000 difference. And for a lot of people on a budget build, $1,000 would go a long way. And that's kind of what the channel is about, doing some really good quality builds, but on a budget, and trying to save the most money as possible. So I'm gonna do the video, try to pass on some techniques and tricks that I've learned as far as using the cheaper machines to get a really good quality weld and get a really strong weld. Now, I will say that my personal opinion is, for a lot of people, that might not be the strongest weld that they can do. Probably just a normal flat, just regular bead, regular weld would probably be a lot stronger. Just for the fact it's so easy to get different problems when trying to stack the dimes. You can get a cold lap or lack of fusion. You definitely got to make sure you tie into both parts if you're doing some kind of like T-joint or tying two pieces together. We'll go over all that in a minute. I had to leave the shop to go pick up some metal. It'll probably be tonight before I'm actually able to film the welding side of this. And we're still waiting on some GoPro equipment, but I'm gonna try to set up a welding lens and set the phone up so maybe I can capture most of the arc shots on the welding and actually be able to see what the puddle's doing, and maybe people can get a better idea of how to manipulate the puddle to get that look. So, about to pull up and pick up the metal. So I'm gonna cut the video off, and then we'll start back filming sometime tonight. So we're back in the shop. We got everything set up. Decided to use some 1/4 inch plate. 1/4 inch be something good to practice on. 3/16 1/4 inch. It'll handle the heat. It's not going to get too hot on you too fast. And most of the time you can go to pretty much any local fab shop wherever you're at, and they'll have small drop pieces like this. Most of them, if you tell them you're just trying to practice and trying to learn, most of them will just give you little drop pieces like this for free. I know I give them away all the time to people around in the area, and it's just some drops. We've got a set of 16-inch custom cut wheels to build tonight, and it's just the drop pieces out of the centers. Just like any kind of welding, the cleaner your metal is, the better off it'll weld. MIG welding's not as picky as TIG welding, but still, the cleaner you can get it, the better weld you're going to get. So we got two of them completely cleaned on the face, and two of them cleaned just on the ends. And we're going to be doing a little T-joint, which would be something good to practice. Weld machine we'll be using is the titanium 170. And I was kind of forced to buy this machine by accident because Everlast shipped me the wrong machines when I'd ordered machines years and years ago. I was going to give the machine away, but it kind of works so good and it's so small and compact, we can kind of push it around easy. I just decided to keep it, and I've been really, really pleased with how it does. We'll be using 75-25 for the gas. You don't really want to MIG weld with 100% argon. I know I've done it before, it'll get you out of a bind, but 75-25 seems to do 10 times better. I'm going to run outside, try to grab a welding lens, put over this camera on the phone. Hopefully we can get some good arc shots and you can actually see what I'm doing. The main thing you're going to want to do is, when you tack your piece up, you can't always tack the far ends and grind them down. So if you ever have to tack the center, or if you have a really big piece and you have to put multiple tacks in it, if you can feather those tacks down, it'll give you a lot more consistent bead. That way when you run up on that tack, you don't have that big glob of metal there to try to flow into it's kind of more flat. If you can TIG weld and you have a TIG welder and you can tack everything with TIG, it'll be a lot flatter and 10 times better for running over with your MIG. So we'll tack both ends there, and basically the technique will be little circles. You'll connect the top, connect the bottom, and then you're going to come out of that puddle forward a little bit, and you'll see you'll leave a little small trail of metal, and then you're going to come back and you're going to fill in right about half of the last circle you did, and then you're going to come forward and then come back and do the same thing, and then come forward. And depending on how hot you're running and how slow you're going will be how big your puddle is and how much you carry when you move. So let me get this tacked up. We'll go outside and try to find a welding lens I can take to this camera, and we'll get to welding. I will go over real fast the settings. 1/4 inch, like I said, to handle the heat. This is probably set pretty close. So, running somewhere around about 18.5 or 18.7 on the volts. Wire speed, let's go 190 on the wire speed, and 18.5. This machine has a dig setting, which you can kind of Google that. It's kind of how much the arc tries to push up into the metal, like dig into the plate. Around 5.5, 5 to 6 is pretty good, depending on what machine you have. For this machine, 5 to 6 works pretty decent. So let me run outside and grab that welding lens real quick and get everything tacked up. So I got everything set up. I think I'll be able to catch the arc pretty decent, maybe to let everybody see the puddle good enough to kind of see what's going on. But the basic idea is you're going to come in, you're going to catch your top, you're going to drag it down to your bottom, and then once you get your puddle as big as you want it by going up and down, you're going to kind of come forward, come out of your puddle, and you'll see your puddle get small. It'll get real small and narrow. You'll pull it forward, and then as you pull forward, you're going to come back and kind of circle right back around and cover about half of your puddle, of your old puddle. And then you're just going to keep doing little circles like that. You'll come over it, come forward, then come back, and just keep going. And the more consistent you get, the better beads you'll start laying. Now, like I said before, you can definitely tell, you know, if we was on a miller, the welds would definitely look a lot better. You can tell, you can watch the voltage kind of go up and down a little bit. You can kind of watch it in the puddle. Wire speed, you can kind of watch it wanting to spit a couple times here and there. So definitely not as consistent as what a Miller or a Lincoln would be, but you'll see we'll definitely get some decent looking welds out of a machine that will save you thousands of dollars, or at least $8,000. So oh, there it is. This is the one that I videoed, and I'm not trying to say, and I don't want anybody to think that I'm trying to say that this Harbor Freight weld machine is as good as a Miller. In fact, I know it's not. We're fixing to order a Miller 252 just because we're doing more products that are MIG welded and less products that are TIG welded. What I am trying to say is, for somebody on a budget that wants to get a really nice weld, this is definitely an option to consider. This was the weld that we videoed here. This was one we just started running another bead right on top of it. The three things that I don't like about the machine is the voltage wants to go up and down. The wire speed will do the same, kind of up and down. And the worst thing about the whole machine is the regulator. You can set it at 12 CFH, and in 30 minutes it might be pumping 30 CFH, or it might be pumping 2 CFH. And if you get too less of gas flow, you're going to start getting porosity, and that's no good. Like, you need to grind it out or throw the part away or start over somehow. too much gas, it'll start wanting to push your puddle around. It's not like TIG welding. TIG welding, you can have a lot of gas flow, and you're kind of controlling how much metal you're putting in, and you can kind of move it around with your tungsten. MIG welding's not that way. You don't want too much gas, and you don't want too less of gas. TIG welding's the same way. For the people that don't know, if you have too less of gas flow, you're going to start getting porosity. If you're doing stainless, you're going to start burning the stainless up. And we'll cover TIG welding later. So that's pretty much it for this. I've got to build these wheels, and we'll probably do a video on these wheels when I build them. I get tons of questions about building custom cut wheels, so we'll probably do a video on that. Just to recap for everybody, what you want to do is you want to come in, connect the top, and then come down to the bottom. Slow. You want to flow your metal. You want to flow it out. And you want to come forward a little bit, and you want to come back up and do the same thing in little circles. Now there's a ton of different techniques you can use to get this. You can do a whip and pause where you lay a bunch and you whip it and you bring it back. But in my personal opinion, this titanium weld machine don't weld good enough to do a whip and pause. So I would highly recommend, if you're using the machine and trying to get the stack of dime deal, just do little circles. And how consistent you come forward and how consistent you come back and lap over your last little puddle is how consistent the weld will be. So get up where you can see it real good, get sturdy, get in a comfortable position, and your welds will come out better than that. And that's pretty much it. So until next time.